Welcome to the deep dive. We've got this stack of sources here all about factorization.
That's right.
And our mission today really is to cut through it all, give you a kind of shortcut to understanding how you break down these algebraic expressions.
Like finding the secret code, almost.
Exactly.
Yeah.
Think of it like the secret handshake of polynomials.
Well, at its core, factorization is just the reverse of multiplication.
Okay.
So instead of taking simple bits and multiplying them up into something complicated,
All right.
we're starting with that complicated expression and trying to find the simpler pieces, the factors that actually built it.
Right, like that classic example you see everywhere, 6 by dollars plus 5x plus 6 cousin.
Mm-hmm.
Factorization is how you figure out, oh, that's just 6x plus 3 times 6 plus 2.
Exactly. Suddenly, it's not just some random trinomial. You see its parts.
Let's see how it's made.
And these sources, they lay out some, key strategies for finding those parts. The very first thing, and they all stress this, always look for common factor.
Right, that's step one. If every single term shares something,
Pull it out.
just pull it out. Like the source example, 6a2, 3a2 as centers.
Yeah.
Both terms have a 3SLer in them. Factor that out, you get 3a2 as
How
sellers,
cool is that?
or 5 by 2 ushers plus 15 2etters. The common factor is 5.
So 5 by 2 at x plus $3. Kind of like finding the greatest common divisor, but with variables too. Always check this first.
Absolutely. It makes everything else potentially much simpler.
Okay, so what if there isn't one single factor common to everything?
Then the sources point towards grouping.
Right. This often comes up when you've got, say, 4 terms, or maybe an even number you can pair up nicely.
Yeah, you group terms that do share a factor inside those little groups.
And hope, basically, that a common bracket pops out.
Like an AB plus BC plus AX plus CXE. You group the first two, AP plus BC.
And the last two, AX plus CX.
First group gives 1A plus C, second gives 6A plus C.
And there it is, that shared bracket, A plus C.
So you factor that out, and you're left with A plus C, B plus X. Done.
It's a neat trick, reorganizing things to see what's hidden.
It's pretty slick. Okay, moving on. Those quadratic trinomials, the x Kadolf-Schüler plus bx plus CD call kind, when grouping isn't immediately obvious.
The sources talk about splitting the middle term. This is, it's fundamental.
Okay.
The whole idea is to break up that middle bx term into 2 new terms, but not just any terms.
Right, you need 2 numbers that add up to the original b.
And crucially, they have to multiply to give you a times c.
Okay, let's use 6 by dollars plus 5x plus 6 again. Here, a is 1, b is 5, c is 6.
So a times c is $1 is $1 times 6, which is 6.
We need 2 numbers that add to 5 and multiply to 6.
That'd be 3 and 2.
So you rewrite 5 by dollars plus 2 girls. The expression becomes 6 by dollars plus 3x plus 2x plus 6 zeros.
And look, now you have 4 terms. Perfect for
Grouping.
exactly.
Right.
6x plus 3 plus 2x plus 3Lers, which gets us right back to 6 plus 3 plus 2.
That connects back. And there's that handy check too, right? The 2, 2, 4 assy thing.
Oh yeah, the discriminant. If P2 is a perfect square, then your trinomial can be factored using rational numbers. It's a quick way to know if it's even possible before you start hunting for numbers.
Super useful check.
Okay.
Beyond those methods, there are specific patterns to spot. The first one is probably the easiest, difference of 2 squared.
Ah, yes. If you see something squared minus something else squared, 6 play 2y 2.
It just factors always.
And to 6 plus yf. It's a formula, basically. 6 plus 5 becomes
6 plus 5.
plus 5, or even something like 16 day 4b4 5. You see it as 4a2 b222.
Okay.
So that's 4a222 plus b2 per 2 with 4a2 b2 and wait, that second bracket.
Oh, 4a2b22, that's 2b2 b2 dpd2,
Wow.
another difference of squares.
Exactly. So it fully factors to 4a2 plus b2, 2a plus b, 2ab. You have to keep looking.
Recognizing that pattern is key. And finally, the other special pattern, sum or difference of 2 cubes.
Right. These are just specific formulas you kind of have to know, or at least know exist so you can look them up.
3 thrallers plus b3 and 3b3
Yes,
flat.
yep. 3 plus b3 is a plus b, a2 plus b2.
Notice the signs, plus, then minus, then plus.
And a3 b3 is ab, a2 plus ab plus b2.
Minus, then plus, then plus.
So if you see, say, $3 plus 27b33.
You recognize 27b33 as 3b3.
Right, so it fits the sum of cubes pattern with a and 3b.
Applying the formula, a plus 3b times a2 ab2 plus 9b2.
Which cleans up to a plus 3b, a2 3b plus 9b2. Spotting these forms saves a ton of time.
Okay, wow. That was a pretty fast tour through the main factorization methods in these sources.
We hit the big ones. Common factors first, always.
Then grouping, splitting the middle term for trinomials.
Difference of squares. and the sum or difference of cubes.
And getting good at these isn't just, for math tests.
Yeah.
It's a really powerful way to simplify things.
It helps you understand the structure, solve equations. You're not just pushing symbols around, you're seeing the actual components.
It really does break down complexity into parts you can actually manage.
And, that makes you think. These seemingly simple rules for breaking down math expressions are fundamental. They let us solve much bigger, more complicated problems. So, here's a thought. What other complex systems out there, maybe not even in math, maybe in science or society or anywhere, could we understand better if we could somehow factor them, if we could find their core interacting components?
Interesting. Factoring the world.
Something to ponder, perhaps, until our next deep dive.